Hey there, welcome to my channel. In this video I'll discuss an idea I had regarding vibrations and cyclic phenomena in general. This idea in particular gives the name to the channel because I think it's quite meaningful. And so without further ado, let's go straight to the point.
So welcome back and let's dive into the subject. So alpha, beyond frequency domain. Disclaimer, somehow, this is just an idea I came up with while I was wondering about the nature of frequency. Hence, no mathematical rigor has been meticulously searched here, so results have been obtained purely in an analogical way and only partly logically. Therefore, mathematicians, IT specialists, physicists, engineers, students, and subject enthusiasts in general, all over the world, are welcome to strengthen the idea or correct it or develop it or else. Also, English isn't my native language, so advices to improve are welcomed. So, summary. Let's start with frequency, philosophical and both physical digression, back to frequency, beyond frequency domain, alpha transform, how and where to use alpha, final recap, conclusion. So let's start with frequency. So omega is equal to 2 pi f, where f is equal to 1 over t. Omega is the angular frequency or pulsation, f is frequency, t is the period. Omega has as unit of measure radians over second, and f has cycles over a second, that is hertz. Also, the angular frequency is also called angular velocity, and this is the key of the reasoning of what I'm about to say. Let's tackle this philosophical and both physical digression. Right before moving on, I'm going to say here quite a bold statement. To me, and this is to me, for real, frequency is cycles over second, not 1 over second, or the inverse of time. This is a subtle but substantial difference to me, as I said, because would you say that velocity or speed or meters over second is the inverse of time? I'd say not. So then why is commonly accepted that frequency is the inverse of time? So to me, and it's to me, time and 1 over time are one the inverse of the other, but not time and frequency. However, we can discuss on this point in another video or elsewhere. So back to frequency. So what is frequency? This is the core of the reasoning. Frequency is the speed or velocity at which a cyclic phenomenon occurs. So once you have clear this idea that frequency is the cyclic and not linear continuous phenomenon speed, you can open the doors to subsequent temporal orders. And I want to clarify my position here. Though the cyclic phenomenon has displacement, velocity, and acceleration that pass through zero, so they are intermittent, to me they are not, because it's the intrinsic nature of the phenomenon that requires the stop and the comeback of the mass. Think, for example, at a uniform rectilinear motion. If that point or mass stops and then restarts, that, to me, is an intermittent motion. Or think at an eccentric mass that, not a mass spring system, that revolves and creates vibration. That motion is continuous. The motion of this mass is continuous. Only the projection of that motion has zeros in displacement, speed, and acceleration. Or still think at a pendulum. Once it reached one extreme of range of motion, it comes back in a continuous motion, not with discontinuities during its arc. And what I mean by that? Think at a pendulum, it goes like this. It doesn't go like this. It's continuous. Of course, it stops and then comes back. But when it starts again, moving from one extreme range of motion is continuous, the motion, not intermittent. However, I'll return on this topic in a video about why amplitude is maximum at resonance. So the first order beyond frequency would be its variation in time, or the equivalent to acceleration or deceleration. That is to say, alpha equals omega over t equals 2 pi f over t, that equals 2 pi over t times f, that equals 2 pi over t times 1 over t, that is equal to 2 pi over t squared, and eventually is equal to 2 pi r, where alpha is angular rapidity, and its unit of measure is radians over second squared, where r is rapidity, and its unit of measure is cycles over second squared, and is equal to Gabriele, because Gabriele is my name, and I gave, of course, my name to this unit of measure. About the angle notation, to me it's theta, it's theta uguale omega t, while phi is left for phase. Hence, for rapidity, theta is equal to alpha t squared. So rapidity is a name I gave to frequency variation. Rapidity is frequency variation that can be positive or negative, while frequency can't, at least in this plane of reality. So going further, we can introduce the equivalent to jerk and jounce, for example, shake and quake, defined as follows. Beta is equal to 2 pi over t cubed, and eventually beta is equal to 2 pi s, where beta is angular shake, and its unit of measure is radians over second cubed. And s is shake, its unit of measure is cycles over second cubed, and I gave the name Neptune because I was thinking at mythology. And gamma is equal to 2 pi over t raised to the fourth power, and eventually gamma is equal to 2 pi q, where gamma is angular quake, and its unit of measure is radians over second raised to the fourth power, and q is quake, its unit of measure is the cycles over second raised to the fourth, and that is equal to Jupiter, always because I was thinking at mythology. To sum up, theta is equal to omega t, or alpha t squared, or beta t cubed, or gamma t raised to the fourth power. Omega is equal to theta over t, or alpha t, or beta t squared, gamma t cubed, and so on. Alpha is equal to theta over t squared, and so on. Omega, alpha, beta, gamma. And in the last position, the physical quantities, frequency, rapidity, shake, and quake, respectively 1 over t, 1 over t squared, 1 over t cubed, 1 over t raised to the fourth power. Of course, all of these exact ratios can be seen as time derivatives too, and I mean these. And of course, the temporal orders can be pushed furthermore, but alpha transform. So now let's move on to something interesting. If we consider the Fourier series, but in alpha key, we can write maybe, here's an example of required mathematical accuracy. I didn't check this mathematically. F of t is equal to a0 plus the summation of the cosines and the sines written in alpha terms, where alpha 0 is the fundamental 2 pi over t squared. If we switch to complex form, we can rewrite with this notation to f of t summation of ci e raised to j alpha t squared, with the usual mathematical trickery. We can go and then taking the limits, we can write down And we arrive to this formula. This is f of t equals 1 over 2 pi integral of f of alpha e raised to j alpha t squared d alpha. This is the inverse alpha or Gabriel transform. I gave my name, of course, to the formula. To compute the direct transform, we can start instead from the complex form of the Fourier coefficients. Once again, this has to be mathematically checked. Ci equals 1 over t square, integral, etc., etc. That leads to f of alpha equals integral of f of t e raised to negative j alpha t squared dt. And this is the direct alpha or Gabriel transform. Unfortunately, the integral is not trivial to compute, and also shifting the variables to utilize the fast Fourier transform algorithm gives a radical into an integral that once again is not trivial. So this is the substitution, and the formula becomes this one, where you can see the radical inside the integral. And of course, the integral can be written for the subsequent temporal orders too, using beta and gamma, where the formula becomes this one. So how and where to use alpha? Another use I hypothesized for rapidity is to study a starting or stopping cyclic phenomenon, so to study the transient phases of motion, but possibly in a Fourier way. That is to say, in an algebraic way, and no more in time domain. This seems not doable, however, because if you plug alpha into the classic equation of motion, time remains in equation itself along with rapidity, so the calculation advantage comes less. See, so this is the equation of motion plus the substitution in terms of alpha. And the third row is the formula, the final formula, in which we can see that time and alpha remain in the equation itself. Maybe we can use it as a parametric equation with time as parameter. As you can see, time is still present, but this I think is related to the fact that at each period the starting or stopping cyclic phenomenon is increasing or decreasing its frequency, so it's not a time invariant situation, of course. Curiously enough, if we use both frequency and rapidity, this is new to me, 21st of October I had this idea of the last year, we can eliminate time and we obtain an equation in two variables or domains, that is to say, the same. Interesting, the fact that damping is affected only by frequency and rapidity works only on mass. This could be the mathematical confirmation to the physics of the phenomenon. Inertia due to acceleration, that means speed variation, is ruled by mass. Damping is, for now, viscous, so depends by velocity only, or frequency. Elastic force feels only displacement. If we push this reasoning to subsequent temporal orders, we obtain the following relationships that are substantially identical to the one using alpha, only numbers change. Another use of alpha could be the study of sweep or chirp signal instead of using omega. For example, a signal made this way, omega of t equals omega 0 t, that is to say, linearly increasing frequency, would become omega 0 is equal omega over t equal constant equal alpha of t, that is to say, alpha of t is constant. Hence, reducing temporal orders or linearizing the problem. I mean, instead of linearly increasing frequency, we take the derivative and consider alpha, or rapidity, as constant. Another use could be when dealing with analytic signal. It seems to me, and I mean to me, 1 over pi t is somehow an operator that takes the derivative of the signal, because pi is a number and 1 over t is the derivative of the signal. The analytic signal is comparing the signal itself with its derivative some way. Therefore, if we move from frequency to rapidity, we somehow deal the same problem. This is in my mind. Though it's not my research field, I just realized some days ago, 21st of March 2023, that all the telecommunications, broadcasting and radio areas of application could benefit from the use of alpha rapidity. Just think at frequency modulation alone, which is exactly frequency variation, where using rapidity might lead to a better comprehension of the phenomenon, as well as maybe to a leaner and clearer theory about it. So, final recap, alpha or rapidity measures the frequency variation or the rate of change of frequency or the rate of change of the cyclic phenomenon velocity. And those are the formula we used. So alpha is 2 pi r, or angular rapidity. R is 1 over t squared rapidity. Unit of measure of alpha is radians over second square. Unit of measure of r is cycles over second square, that equals Gabriele. And the direct or Gabriele transform, f of alpha, and the inverse alpha or Gabriele transform, which is f of t in terms of alpha. And so this is the idea about alpha rapidity. Feel free to comment or contact me, and because we are on YouTube, please subscribe and click on the notification bell to receive updates on this and other ideas that I'll share more or less soon. And consider to give a thumb up too, and share link or talk of this video with anyone that could be interested in this topic. So until next time or video, stay strong.